the mind-bending numbers. So here's the deal. The observable universe is about 93 billion light years across. Yeah, you read that right. 93 billion. With a B. That's the diameter we're talking about. Which means if you could somehow travel from one edge of what we can see to the other edge, you'd cover that entire distance. And before you ask, yes, that number seems completely bonkers when you consider the universe is only 13.8 billion years old. How does something that's been around for less than 14 billion years end up being so impossibly wide? Stick with me here, because this is where things get really interesting. The universe isn't just big, it's expanding in a way that actually stretches the very fabric of space itself. Charles Liu, the astrophysicist from the College of Staten Island, who co-wrote One Universe, At Home in the Cosmos, with Neil deGrasse Tyson, puts it brilliantly when he describes how galaxies are to the universe as cells are to the human body. Each one is its own little world, but together they make up something incomprehensibly larger. And Neil deGrasse Tyson himself has said that calling the universe astronomically large isn't just a figure of speech. It's literally the most accurate way we can describe it, because we invented that word specifically for this kind of scale. Now, when you look out into space with a telescope, you're not just looking far away, you're looking back in time. Light travels at about 670 million miles per hour, which sounds fast until you realize it still takes 8 minutes for sunlight to reach Earth. When we look at distant galaxies, we're seeing them as they were billions of years ago, because that's how long their light has been traveling to get here. The cosmic microwave background radiation, that leftover glow from the Big Bang, was emitted about 380,000 years after the universe began. But here's the kicker. The matter that emitted that radiation is now roughly 46 billion light years away from us, because space itself has been expanding this whole time. Hey, real quick before we dive deeper into this cosmic rabbit hole, if you're enjoying this breakdown of how absurdly huge our universe actually is, do me a solid and hit that like button. And if you haven't subscribed yet, what are you waiting for? We're covering everything from satellites to supernovae, black holes to the Big Bang, and trust me, you don't want to miss what's coming next in this video. Seriously, the controversial stuff we're about to get into is going to blow your mind. The observable universe versus everything else. Here's where it gets philosophical and scientific at the same time. The observable universe is everything we can theoretically see or detect from Earth. It's like standing on a beach and looking out at the horizon. You can only see so far before the curve of the Earth blocks your view. Same principle applies to the cosmos, except instead of being limited by Earth's curvature, we're limited by the finite age of the universe and the speed of light. There are regions whose light simply hasn't had enough time to reach us yet. But, and this is crucial, just because we can't see beyond that horizon doesn't mean there's nothing there. In fact, most astrophysicists agree that the total universe is probably much, much larger than the observable part. It might even be infinite, though that's a concept that makes even physicists uncomfortable, because how do you study something infinite? Charles Liu has described the cosmic pathway at the Hayden Planetarium, which spans more than a football field and represents 13 billion years of cosmic history. You know what's wild? All of recorded human history fits within the width of a single human hair on that scale. As Liu himself noted, it really shrinks your head. Had a bad day at work? Well, in the grand scheme of things, your Monday morning meeting probably doesn't rank too highly on the cosmic importance scale. How fast is fast enough? Let's tackle that age versus size paradox head on, because it trips up a lot of people, and rightfully so. If nothing can travel faster than light, shouldn't the farthest thing we can see be 13.8 billion light years away? Which would make the universe only 27.6 billion light years across, right? Wrong. And here's why. The expansion of space itself isn't bound by the speed limit that applies to objects moving through space. Think about it this way. Imagine you're standing on one of those moving airport walkways. You know, the ones that carry you along while you're just standing still. Now, imagine that walkway is stretching while you're on it, getting longer and longer. The distance between you and someone at the other end isn't just growing because you're moving. It's also growing because the walkway itself is expanding. That's basically what's happening with space. Those distant light sources aren't just sitting where they were when they emitted their light. They've been carried along by the expansion of space, and they're now about 46 billion light-years away in every direction. The National Radio Astronomy Observatory points out that these distant galaxies have moved roughly 30 billion light-years in the time since the Big Bang, which works out to about 2.5 times the speed of light. But they haven't violated physics because they're not moving through space faster than light. Space itself is expanding and carrying them along. What's actually out there? Neil deGrasse Tyson loves to put the numbers into perspective. The observable universe contains approximately 2 trillion galaxies. That's a number that was revised upward significantly in recent years as our telescopes got better. Each galaxy contains upward of 100 billion stars. Do the math on that? We're looking at more stars than all the grains of sand on every beach on Earth. And astronomers now recognize that planets are incredibly common, with estimates suggesting there are likely more planets than stars in the universe. The Milky Way itself is just one galaxy in the local group of galaxies, which is itself part of the Laniakea supercluster, which spans over 500 million light-years. And the largest known void, which is basically empty space between galactic structures, measures 1.8 billion light-years across. Empty space that's nearly 2 billion light-years wide. Let that sink in for a moment. Between the larger structures are voids that typically range from 33 million to 490 million light-years in diameter. These aren't completely empty, but they're about as close to nothing as you can get in the universe. Meanwhile, typical galaxies range from dwarfs with as few as 10 million stars, up to giants with 1 trillion stars. The sheer variety of scales we're dealing with is staggering. Alright, we're getting into the really wild stuff now, so if this is blowing your mind even a little bit, make sure you're subscribed, because we're about to talk about whether there might be infinite copies of you living in parallel universes. Yeah, seriously. But before we get there, smash that like button so this video gets recommended to other space nerds who need to know this stuff. The multiverse controversy. Now we're entering territory that makes some astrophysicists absolutely furious and others absolutely convinced. The multiverse hypothesis suggests that our universe might be just one of many, perhaps infinitely many, universes that exist. And depending on which version of multiverse theory you're looking at, these other universes might have completely different physical laws, different numbers of dimensions, different values for fundamental constants like the speed of light or the strength of gravity. Charles Liu and other physicists who study cosmic inflation and quantum field theory point out that if these two well-established theories are both correct, then a multiverse isn't just possible, it's inevitable. Here's the logic. Cosmic inflation is the rapid expansion that preceded the hot Big Bang. If inflation behaves like a quantum field, which all evidence suggests it does, then there should always be regions of space that are still inflating while other regions have stopped and created their own Big Bangs. This creates an infinite number of bubble universes, each with its own Big Bang, popping into existence eternally. Max Tegmark, a cosmologist at MIT, has classified multiverses into 4 different levels. Level 1 is pretty tame. It just suggests that if space goes on forever in our own universe, eventually you'll find regions where particles have arranged themselves exactly the same way they have here, meaning there could be infinite copies of you somewhere out there in the infinite expanse. Level 2 gets weirder, suggesting that eternal inflation creates infinitely many pocket universes, where the laws of physics are actually different. Level 3 brings in quantum mechanics and the many worlds interpretation, where every quantum measurement creates new branches of reality. Level 4 goes completely off the rails and suggests that every mathematically possible universe actually exists. Neil deGrasse Tyson has discussed how the universe we observe has some remarkably fine-tuned properties. The constants of nature have values that fall within an extremely narrow range that allows for complex structures and life to exist. Change the strength of gravity by even a tiny percentage, and stars don't form. Change the electromagnetic force, and atoms don't hold together properly. The multiverse hypothesis offers one potential explanation. If there are countless universes with all possible values for these constants, then of course we find ourselves in one where the values work out, because we couldn't exist in the ones where they don't. It's called the anthropic principle, and it's either brilliant or a cop-out depending on who you ask. The critics fight back. But hold on, not everyone's buying it. In fact, some prominent physicists think the multiverse is, and I quote, pseudoscientific bullshit. Paul Davies from Arizona State University argues that invoking infinite, unseen universes to explain our universe is just as much a leap of faith as invoking an unseen creator. He points out that the multiverse theory doesn't really explain anything. It just pushes the mystery back a level. Instead of asking why our universe has the properties it does, now we're asking where the universe-generating mechanism came from and what laws govern it. You still need physics to make all those big bangs go bang. The fundamental problem with multiverse theories is that they might be completely untestable. If these other universes lie forever beyond our cosmic horizon, beyond any possible observation or measurement, then is the multiverse really a scientific theory at all? Science is supposed to be about making predictions that can be tested and potentially falsified. George Ellis and Joe Silk, both respected astrophysicists, have warned that promoting untestable theories as established science threatens the credibility of physics itself. They invoke mathematician David Hilbert's warning that although infinity is needed to complete mathematics, it occurs nowhere in the physical universe. John Horgan, a science writer for Scientific American, has been particularly blunt, calling multiverses escapist pseudoscience and comparing them to billionaires fantasizing about colonizing Mars instead of solving Earth's real problems. He argues that while multiverse theories make for great thought experiments and entertaining science fiction, they cross a line when physicists claim they're established scientific facts. In his view, science is already in a credibility crisis, and promoting ideas that can never be tested only makes things worse. But wait, there's more. However, not everyone agrees that multiverses are completely untestable. Some researchers have proposed that if bubble universes exist and they occasionally collide with ours, we might see evidence of those collisions in the cosmic microwave background radiation. Rangaram Cherry, working with data from the Planck satellite, has identified some strange anomalies in the CMB that could potentially be explained by such collisions. It's controversial, it's speculative, but it offers at least the possibility of making the multiverse hypothesis testable. The debate gets heated. At a 2007 conference on quantum interpretations, physicist Andy Albrecht called the theoretical work supporting multiverses one of the most important developments in the history of science. Meanwhile, philosopher Hugh Price, attending the same conference, found the arguments fundamentally flawed. That's where we are right now. Brilliant minds looking at the same theories and reaching completely opposite conclusions. Welcome to the cutting edge of cosmology, where nobody agrees on anything. What it all means for us. Neil deGrasse Tyson often talks about the cosmic perspective and how it can either be terrifying or enlightening, depending on how you approach it. Some people learn about the scale of the universe and feel utterly insignificant, depressed by the realization that we're just tiny specks in an incomprehensibly vast cosmos. But Tyson argues that's the wrong way to look at it. Yes, we're small, but we're also connected to the universe in profound ways. Every atom in your body was forged in the heart of a dying star billions of years ago. We're literally made of stardust, the universe made conscious, capable of understanding itself. Charles Liu writes about how creativity and imagination, combined with our ability to build tools and machines, have allowed us to unravel mysteries that seemed forever beyond our reach. Just a century ago, we thought the Milky Way was the entire universe. Edwin Hubble, using the Hooker telescope, proved in the early 1920s that other galaxies existed, and suddenly, the universe got a whole lot bigger. Now, we know there are trillions of galaxies. Who knows what we'll discover in another century, or another millennium? In his book, The Cosmos Explained, Liu notes that while Earth will eventually be incinerated by the Sun in about 5 billion years, right around the time the Milky Way smashes into the Andromeda Galaxy, we've got plenty of time to figure out how to survive it all or get off this planet. As he points out, 1 billion years ago, the most complicated life form on Earth was a slime mold. Can we even imagine what it'll mean to be human 1 billion years from now? The bottom line. So when someone asks, how big is the universe? The honest answer is, we don't really know. The observable universe is 93 billion light years in diameter, containing around 2 trillion galaxies, but the total universe could be vastly larger, possibly infinite. It's been expanding for 13.8 billion years, and that expansion is accelerating thanks to something we call dark energy, which is itself one of the biggest mysteries in physics. Whether there are other universes beyond ours remains one of the great unsolved questions of physics. Some of our best theories suggest they must exist. Other equally smart physicists think those theories are leading us astray. The debate continues, sometimes politely and sometimes not so politely, in the halls of universities and at conferences around the world. What we can say for certain is that the universe we inhabit is far stranger and more magnificent than our ancestors ever imagined. It challenges us to think bigger, to question our assumptions, and to remain humble in the face of cosmic mysteries that might take us centuries or longer to solve. The universe literally encompasses everything we were, are, and will be, everything we knew, know, and can know. That's a quote from Charles Liu, and it captures the sheer audacity of what we're trying to understand when we study cosmology. If this journey through cosmic scales and controversial theories got your neurons firing, then you absolutely need to subscribe to this channel right now. We're diving deep into the mysteries of space, from the satellites orbiting Earth to the supermassive black holes lurking at the centers of galaxies billions of light years away. We're covering the confirmed science and the wild speculation, the stuff we know, and the stuff we're still arguing about. Hit that subscribe button, ring the notification bell, and join us as we explore everything from the smallest particles to the largest structures in existence. Because the universe isn't going to explain itself, but together, we can sure try to understand it. Clear skies, everyone.